So the old saying, what goes up must come down, exists because of Isaac Newton's theory of universal gravitation. Yes, I am a fan of that dude. He was the man and I can prove it.
We got people slogging through calculus in college just to learn what it is that Isaac Newton invented on a dare, practically. So that's my man.
Told you, I'm out. Nah, just kidding, the video's not over. Recently, Michael from the channel Vsauce tweeted a slightly more accurate spin on that old saying, which I thought was pretty good. Isaac Newton's theory of universal gravitation is among the greatest achievements in science. The theory states that there is a mutual attraction between anything that has mass, and this attraction is dependent on three things: the mass of each object, the distance between the objects, and a number called the gravitational constant. There's a link to more info about this number in the doobly-doo. One of the central themes of Newton's theory is that the gravitational force follows an inverse square law, meaning that the strength of the attraction between two objects changes exponentially with respect to the distance between them. The equation used to represent universal gravitation is written like this. It says the force due to gravity between two objects is equal to the gravitational constant times the product of the object's mass divided by the square of the distance between them. To simplify this concept, let's imagine that there are two planets floating in space. Newton's theory says that gravity is the force that draws these planets closer together based on their masses and how far apart they are from each other. The inverse square law tells us that if the distance between the two planets doubles, for instance, then the strength of the gravitational force between them will only be 1/4 as strong as it was previously. Similarly, if the distance between the planets is cut in half, then the force of gravity will be 4 times as strong. Matter of fact, Newton's formulation of the theory was so accurate that it immediately explained the motions of the planets, creating an easy way to predict their movements relative to each other and the sun. Newton's cannonball is one of his famous thought experiments, which appeared in his 1728 book, A Treatise of the System of the World, that he used to hypothesize that the force of gravity was universal and was the key force for planetary motion. In this experiment, Newton visualizes a cannonball being fired from the top of a very high mountain. If the speed of the ball is too low, it will simply fall back to Earth. But if you continue to increase the speed at which the ball is fired, you would eventually send the ball flying at a horizontal velocity that would be equal to the force of gravity, which is trying to pull the ball down to the Earth. At this point, the cannonball will be moving fast enough to essentially continue falling around the curvature of the Earth. This is what's called an orbit. So now think about the International Space Station that's up there orbiting the Earth. It's traveling at a speed of over 17,000 miles an hour, which is fast enough that it's just constantly falling around the Earth. Yes, this is very fast. The space station orbits the Earth once every 90 minutes, so this means that the astronauts on board get to witness the sunrise and sunset about 16 times a day. So yeah, Newton was right, again, and orbits due to gravity are a thing. Just like the space station, the moon constantly falls around the Earth constantly falls around the sun, and the sun constantly falls around the supermassive black hole at the center of the Milky Way galaxy. One example of his theory being put to use was in 1845, when John Couch Adams and some French dude predicted the existence of a new yet unseen planet based on small discrepancies found in the orbit of Uranus. Then, in 1846, the German astronomer Johann Galle confirmed the predictions and officially discovered the new planet Neptune. So I think this would be a great time to transition into the obligatory Uranus jokes. Uranus is more than 30,000 miles wide. This just in. Scientists have discovered a ring of debris around Uranus. I just got back from the museum, and while I was there, I saw a scale model of Uranus. Due to the poisonous gases that exist, man cannot survive anywhere near Uranus. You know, they recently found life on Uranus. You should probably get that looked at. They probably have a cream or something. Hey, yeah, no, I'm at home. Hey, dummy. Yeah. He's sitting right here. He's trying to tell me something. Alright, fine. What? Did you know that Uranus has a hole in it? No, what's it called? Your rectum. Get it? Your rectum? That was stupid. I know. Okay, no more farting around. Let's go ahead and wrap this up. Besides, nothing interesting ever happens on Uranus. In 1705, Sir Edmund Halley correctly predicted that the famous comet of 1682 would return 76 years later in December of 1758. Halley had used Newton's law to predict the behavior of this comet, and sure enough, on Christmas Day of 1758, the comet was spotted making its return trip around the sun. After that, it was named Halley's Comet, and math for the win. While Newton's theory of universal gravitation remains very useful today, Albert Einstein demonstrated in 1915 that it wasn't quite the final word, in that it fails to work when gravitation becomes extremely strong. Nonetheless, Newton's gravitational constant plays an important role in Einstein's theory of general relativity, in which he explains that the force of gravity is not an attractive force, but rather the result of a curvature in the fabric of spacetime caused by energy and momentum. But that is a topic for another time because Einstein.
Another smell commonly associated with rain comes from the volatile oils that trees and other plants release.
While everyone else is reaching for the stars, I'm reaching for Uranus.